So this counting video is going to be more in-depth about permutations, and this is basically permutations part 2. So let's get started. So the permutations we've seen so far are basic ones, like let's say someone asks you to arrange the word hi. You know, it's just 2 factorial, which is just IH and I. Those are the only 2 ways you can arrange the words, and we're gonna work our way up here. So we're gonna start with a basic problem. We're gonna arrange HH. Now, looking at this, you might just say 1, which you're right, there is 1. But we're gonna find out how we get to this answer of 1. So if, let's say, we replace this H with an I, we know how to handle this. We just do a 2 factorial. And 2 factorial is just 2. So you would say there are 2 ways. But here we have an H, which is the same as the first element. So the first letter is H, the second letter is H. So since we have 2 words here that are repeated, we're gonna divide by 2, because let's say these H's were different, we would do a 2 factorial, but since they're the same, we need to divide by 2 to get rid of the overcounting that we did. 2 factorial is 2, and 2 divided by 2 is just another way of saying 1. So that's how we get to our answer of 1. And now we're going to work our way up. We're going to arrange, let's say we have hello. Hello. So same strategy last time. What we want to do here is we want to treat this as if these L's were different letters. So let's say the L was just a K. Helco. Let's say it was a Helco or something. And this K right here, if these are different, that's just 4 factorial. But this K does not exist. We just made it up. And we see that these L's, there are 2 of them. So we divide by 2. 4 factorial is 24. 24 divided by 2. The answer is 12. Now, we're going to manipulate this a little bit. And let's say this is going to be a little harder. The word Alabama has a lot of repeated elements, so we obviously want to count the number of ways we can arrange Alabama. It's a pretty long name even for a state, but regardless of that, we want to count the number of ways we can arrange it. So here we have an A, that's repeating. So really the only thing that's repeating is the A, and we also have the big A in the beginning. The only different letters we have is M, B, and L. So we can put these aside. And then we're going to have A, and another A. That's our main focus. And we know this is just 1. But to get Alabama, we need to include the L, B, and M. So first we're going to do the same thing. Pretend these A's are all different. Let's say this is the A, this is J, this is I, this is K, and right now this is how many we're going to count the number of letters first. 1, 2, 3, 4, 5, 6, 7. So there's 7 letters, 7 factorial, if they were different, but that does not exist. This does not exist. There is no I, there is no J, and there is no K. So, since there is no J, K, or I, we're going to have to find a different way to approach this problem. And a way we can think about this is how we solve simpler problems, how we solved with two repeated elements. We divide by two the number of things we do here. We have to think about this. The number of repeated elements here is a lot. We have lots of repeating elements. We have 4 repeated elements. We have 4 A's. If we can find the number of ways to arrange these 4 A's, if the A's were different, let's say this is just B, D, C, A, we'd have 4 factorial ways to arrange this. And since we have a similar thing here, we divide by a 4 factorial. And 7 factorial divided by 4 factorial is our answer, which can be simplified as 210. So that's how we would approach this type of problem. Now let's take a look at a little more difficult problem, which involves repeated elements with multiple letters. And this is a neighboring state to Alabama. So let's say we have the word Mississippi. Lots of repeated elements here. We have the M is really the only thing that is not repeated. So honestly, we're going to rewrite the word here. We don't need the M for now. We're going to focus on this. Lots of repeated elements. We're going to circle the repeated elements here. So we're going to do it over here. I's. There's 4 I's. And there's 1, 2, 3, 4 S's. And then we have 2 P's. And if we were to put all of these together as different, well, we would have a 4 factorial times a 4 factorial times a 2, or another 2 factorial, which is 2 obviously, but that's what we would have to arrange these 3 ways, because the S or the I can be either one of these 4 factorials. I can do an I here and an S here. And this is the P. We can arrange the P 2 different ways if these were different. And if we want to combine this entire thing, if these were all different, we would have this. So in one way, these are equal if these were sort of different. So let's say we have all of these different letters, we would arrange it like this. So back to our original problem here. We know how to handle this. So now that we know how to take care of this, we are going to approach this problem again. So first step, we count the number of letters. 1, 2, 3, 4. So 11. 11 factorial. And we divide it by 4 factorial is 24. And that's our answer. So hopefully this video is helpful. That is another example of permutations. And yeah, that is Permutations Part 2.